4 solutions to the Fermi paradox. Look up at the night sky. Those stars you see are just a tiny fraction of the 200 billion stars in our galaxy. And our galaxy is just one of 2 trillion galaxies in the observable universe. Conservative estimates suggest there are more planets in the universe than grains of sand on all of Earth's beaches. Trillions upon trillions of worlds. Many of them in habitable zones around their stars. Life arose on Earth relatively quickly, within a few 100 million years after conditions became suitable. Intelligence evolved in less than 4 billion years. We went from stone tools to radio telescopes in 10,000 years. Given these numbers, the universe should be teeming with alien civilizations. Thousands in our galaxy alone. Some billions of years more advanced than us. So where is everybody? This is the Fermi paradox, named after physicist Enrico Fermi, who asked this question in 1950. The contradiction between the high probability of alien life and the complete absence of any evidence for it. We've been listening for signals for decades. Scanning thousands of stars. Looking for any sign of intelligent life. And we've found nothing. Complete cosmic silence. Today we're exploring 4 solutions to the Fermi paradox. 4 possible explanations for why we're alone. And I'm warning you, each one is disturbing in its own way. First, the Great Filter. Something kills civilizations before they can spread to the stars, and we might be approaching it. Second, the Dark Forest theory. Civilizations hide because the universe is a hostile place where revealing yourself means death. Third, the zoo hypothesis. We're being watched but deliberately not contacted, like animals in a nature preserve. And finally, the rare Earth hypothesis. We're actually alone, the only intelligent life in billions of light years, and the silence is real. By the end of this video, you'll understand that every solution to the Fermi paradox is unsettling. Either we're about to die, we're being hunted, we're being studied, or we're cosmically alone. There are no comforting answers to where are the aliens. Only increasingly disturbing possibilities. Let's begin with the solution that suggests our future is already determined. Chapter 1. The Great Filter. Something kills every civilization before they reach the stars. Imagine there's a wall. An evolutionary barrier that virtually no species can cross. A filter so devastating that 99.99% of civilizations die trying to pass through it. This barrier could be behind us, something incredibly unlikely that we've already overcome. Or it could be ahead of us, something waiting to destroy us like it's destroyed every other intelligent species in the galaxy. This is the Great Filter. And it's the most terrifying solution to the Fermi paradox. Because if the filter is ahead of us, we're doomed. Let's establish the problem. The Drake equation estimates how many communicative civilizations should exist in our galaxy. Rate of star formation, 7 new stars per year. Fraction with planets, 100% planets in habitable zones per star, 1 to 2 on average. Fraction where life develops. Unknown, but even if it's 1%, that's millions of planets. Fraction where intelligence evolves. Unknown. But even if it's 0.1% of life-bearing planets, that's thousands. Fraction that develop technology. Unknown, but we did, so it's possible. Even with extremely conservative estimates, there should be thousands of detectable civilizations in our galaxy right now. But we detect 0. Complete silence. This means one of those probability factors is catastrophically wrong. There's a step that almost no civilization passes. A Great Filter. The Great Filter could be behind us. Maybe the hard step was something we've already achieved. Filter 1. Origin of life. Maybe life itself is incredibly rare. Maybe Earth got astronomically lucky. Maybe abiogenesis, non-living chemistry becoming living biology, is so improbable that it's only happened once in the galaxy. If this is the Great Filter, we're safe. We passed it. But it also means we might be the only life in the galaxy. Not just the only intelligence, the only life. Complete cosmic isolation. Filter 2. Eukaryotic cells. Maybe the jump from simple prokaryotic cells to complex eukaryotic cells is the filter. This took 2 billion years on Earth, half the time life has existed. Maybe it's so unlikely that most planets with simple bacteria never evolve complexity. Filter 3. Intelligence. Maybe intelligence is the filter. Maybe evolution rarely produces brains capable of technology. Earth has had millions of species over billions of years, and only one developed civilization building intelligence. If intelligence is the Great Filter, and we've passed it, that's good news. We made it through. But there's a terrifying alternative. What if the Great Filter is ahead of us? What if the reason we don't see alien civilizations is that they all destroy themselves shortly after reaching our level of technology? Think about where we are as a species. We have nuclear weapons capable of destroying our civilization. We're changing our climate faster than evolution can adapt. We're developing artificial intelligence that might surpass and replace us. We're editing genes, creating synthetic biology, building technologies that could end us. And we've had this level of technology for less than a century. A cosmic blink. We're babies playing with grenades. What if every civilization reaches this point, this vulnerable period where they have world-destroying technology but lack the wisdom to manage it? And what if virtually all of them fail? What if the Great Filter is the transition from planetary civilization to spacefaring civilization? And what if almost no one survives it? What kills civilizations at our level? Several candidates. Nuclear self-destruction. We came terrifyingly close during the Cold War. We have enough weapons to create nuclear winter, killing most complex life. One miscalculation, one accident, one irrational leader, and it's over. Climate collapse. We're conducting an uncontrolled experiment on our planet's climate. If we trigger runaway feedback loops, melting permafrost releasing methane, dying ocean algae reducing oxygen production, we could make Earth uninhabitable. Artificial intelligence. We're building minds that might surpass human intelligence. If we get alignment wrong, if we create super-intelligent AI with goals that don't include preserving humanity, we're extinct. And we have no idea how to solve the alignment problem. Engineered pandemics. As biotechnology advances, it becomes easier to engineer deadly pathogens. Eventually, the knowledge to create civilization-ending viruses will be accessible to individuals. One malicious actor, one accident, one containment failure. Nanotechnology. Molecular manufacturing could lead to self-replicating machines. If we lose control, the Grey Goo scenario, self-replicating nanobots could consume all organic matter on Earth in days. Resource depletion. Maybe civilizations exhaust their planet's resources before achieving sustainable technology. Population collapse. Societal breakdown. Permanent regression to pre-industrial levels, never to recover. If any of these is the Great Filter, and it lies ahead of us, then our future is grim. Because it suggests that virtually every civilization that reaches our level dies within the next few centuries. Here's the most terrifying aspect of the Great Filter theory. Finding alien life would be bad news. If we discover simple bacterial life on Mars or Europa, that's very bad. Because it means the origin of life is not the Great Filter. Life is common. Which means the filter is ahead of us. Something kills civilizations after they develop. And we're approaching it. If we discover ruins of a dead alien civilization, ancient cities, artifacts, evidence they existed and died, that would be the worst possible discovery. Proof that civilizations arise and then die. That the Great Filter kills consistently. The best-case scenario for humanity is that we never find any life anywhere. That life is incredibly rare. That we pass the Great Filter when we evolved from chemistry to biology, or from simple cells to complex ones. Because if life is common, and intelligence is common, but civilizations are absent, the only explanation is that something kills them all. Are we about to face the Great Filter? Are we living in the critical century where humanity either becomes a spacefaring species or joins the cosmic graveyard of failed civilizations? We don't know. But the silence of the universe suggests that making it through this period is extremely difficult. Maybe we're the first to get this far. Maybe we'll be the ones to break through. Or maybe, like countless civilizations before us, we'll destroy ourselves within the next few hundred years. But there's another possibility. Maybe civilizations don't destroy themselves. Maybe they're killed. Maybe the universe is far more hostile than we imagine. Let's talk about the Dark Forest. Chapter 2. The Dark Forest Theory. The universe is a hunting ground, and revealing yourself is death. Imagine you're alone in a dark forest at night. You can't see more than a few feet ahead. You know there are others in the forest. You can hear distant sounds. Breaking twigs. Movement in the brush. But you don't know if they're friendly or hostile. You don't know if they're prey or predators. And they don't know the same about you. So what do? Do you call out, announcing your location? Or do you stay silent, hidden, waiting to determine the nature of the others before revealing yourself? The Dark Forest Theory says the universe is this forest. And any civilization that announces its presence doesn't survive. The dark forest theory was popularized by Chinese science fiction author Liu Cixin in his Remembrance of Earth's Past trilogy. But it's based on serious game theory and strategic analysis. The theory starts with two axioms. 1. Survival is the primary need of civilization. 2. Civilizations expand and need resources, but the total matter in the universe is finite. From these axioms, the theory derives a dark conclusion about first contact. When two civilizations encounter each other, they face a prisoner's dilemma with cosmic stakes. You detect another civilization. What do? Option 1. Make contact. Try to communicate. But you don't know their intentions. They might be peaceful. Or they might view you as a threat. Or a resource to exploit. Even if they're currently peaceful, you don't know their future intentions. Civilizations change. Leadership changes. A peaceful civilization might become aggressive. And there's a fundamental problem. You can't verify their intentions. They could be lying. Could be friendly now and hostile later. You can't trust them. Worse, there's a technological gap issue. If they're more advanced, they might view you as we view bacteria, not worthy of moral consideration. Or as a threat to eliminate before you become dangerous. Option 2. Preemptive strike. Destroy them before they can threaten you. This sounds monstrous. But from a pure survival standpoint, it might be rational. If survival is your primary goal, and you can't verify another civilization's intentions, and allowing them to continue existing poses a potential future threat, then the safest option is elimination. You don't know if they're peaceful or hostile. But you know that if you destroy them now, they'll never become a threat. Certainty versus uncertainty. And there's another problem: chains of suspicion. Even if you believe they're peaceful, you don't know if they believe you're peaceful. They might attack you preemptively because they fear you. And even if you both believe you're both peaceful, you don't know if the other thinks you think they're hostile, causing them to preemptively attack you for self-defense. It's an infinite regress of suspicion. No way to establish trust. No common ground to build diplomacy on. So what's the rational strategy? Silence. Concealment. Stay hidden. Don't broadcast your location. Don't send signals into space. Don't build megastructures that could be detected from light years away. Stay dark. Stay quiet. And if you detect another civilization, you face a brutal choice. 1. Ignore them and hope they don't detect you. 2. Monitor them closely and prepare to destroy them if they become a threat. 3. Destroy them immediately as a precaution. The dark forest theory suggests that option 3, preemptive destruction, is the norm. That the universe is filled with hunter-killer civilizations that destroy any detected civilization immediately. Not out of malice. Not out of cruelty. Out of cold, rational self-preservation. You can't afford to wait and see if they're hostile. By the time you know, it might be too late. So you strike first. If the dark forest theory is correct, humanity has made catastrophic mistakes. We've been broadcasting radio signals into space since the 1930s. We've sent deliberate messages to nearby stars. We launched Voyager probes with golden records showing Earth's location. We've been shouting into the dark forest, "We're here. Come find us." If there are predator civilizations out there, listening, we've given them our coordinates. Announced our existence. Painted a target on Earth. And we can't take it back. Those signals are traveling at light speed. They're already tens of light years away, spreading outward in an ever-expanding sphere. If a civilization 50 light-years away detected our earliest broadcasts, they've known about us for decades. And we won't know they know until their response arrives. Which could be a relativistic kill vehicle, a projectile traveling at near-light speed that would obliterate Earth. We wouldn't see it coming. No warning. Just sudden extinction. The dark forest theory explains the Fermi paradox perfectly. Where are the aliens? Hiding. Just like we should be. Every civilization that survives long enough learns the rules. Stay quiet. Stay hidden. Don't reveal yourself. The loudest civilizations die first. The universe isn't empty. It's full of civilizations. But they're all concealing themselves. Operating under maximum stealth. Avoiding detection at all costs. Because the first rule of survival in a dark forest is, don't make noise. Is the dark forest theory accurate? Maybe not. There are counter-arguments. 1. Mutual assured destruction. If all civilizations have weapons of mass destruction, attacking means retaliation. Like Earth's Cold War, deterrence might prevent strikes. 2. Post-scarcity. Advanced civilizations might have abundant resources through stellar engineering. No need to compete violently. 3. Ethical evolution. Maybe civilizations that survive tend to develop ethical frameworks that prevent genocide. Moral progress accompanying technological progress. 4. Diverse motivations. Not all civilizations prioritize survival above all else. Some might value knowledge, art, communication. But these counterarguments assume rationality, cooperation, and shared values. History suggests otherwise. Humans have barely avoided self-destruction multiple times. We've committed genocides, started wars, destroyed ecosystems, and we're all the same species. Expecting different species, with alien psychology, alien values, alien evolution, to be peaceful and cooperative might be naive. The dark forest theory is pessimistic, but it's consistent with game theory, evolutionary psychology, and historical precedent. Maybe the universe is a dark forest. Maybe civilizations that survive are those that mastered the art of silence. Maybe we've already made fatal mistakes by broadcasting our existence. Or maybe there's another explanation for the silence. Maybe we're not in danger. Maybe we're being watched, studied, deliberately not contacted. Like animals in a zoo. Let's talk about the zoo hypothesis. Chapter 3. The zoo hypothesis. We're being watched but not contacted. Imagine you're a scientist studying a newly discovered tribe in a remote jungle. They've never encountered modern civilization. They have their own culture, beliefs, technology. Do you make contact? Introduce yourself? Or do you observe from a distance, documenting their development without interference? Most scientists would choose observation. Avoid contaminating the study. Let the tribe develop naturally. Maybe establish contact later, when they're more technologically advanced. The zoo hypothesis says we're the tribe. And advanced alien civilizations are the scientists. Watching us. Studying us. Deliberately not making contact. We're in a cosmic zoo. Or a nature preserve. Or a quarantine zone. And they're observing from a distance. The zoo hypothesis was formally proposed by radio astronomer John A. Ball in 1973, though the idea existed earlier in various forms. Ball argued that the absence of detected aliens could be explained by a policy of non-interference. Advanced civilizations might have agreed, through a galactic club or interstellar treaty, not to contact emerging civilizations. Why? Several possible reasons. Reason 1. Avoiding cultural contamination. Contact with vastly superior technology could destroy our civilization. Not through war, but through cultural shock. If aliens landed tomorrow and offered us fusion power, room temperature superconductors, and faster-than-light travel, what would happen to our civilization? Our economies would collapse. What's the value of oil when you have fusion? Of computer chips when you have quantum computing 1,000 years more advanced? Our religions might collapse. If aliens confirmed they visited hundreds of planets with life, that God never mentioned them, that our religious texts are provincial and earth-centric, what happens to faith? Our sense of achievement would collapse. We landed on the moon. We're proud of that. But if aliens show us their intergalactic empire, our accomplishments seem like a child's finger painting to a master artist. Contact might psychologically break us. Depression on a civilizational scale. Loss of purpose. Loss of identity. Societal collapse. So maybe they're waiting. Letting us develop on our own. Letting us discover these technologies ourselves so we earn them. So we maintain our dignity and sense of accomplishment. Reason 2. Scientific value of natural development. If you're studying the evolution of intelligence, the development of civilizations, the emergence of technology, you need control groups. You can't study how civilizations naturally develop if you keep interfering with them. You need to let them progress independently. We might be one of many control planets in a massive, galaxy-spanning anthropology study. Observed but not contacted. Allowed to develop naturally to provide data on how intelligence evolves without external influence. Which means every decision we make, every war, every discovery, every cultural shift, might be recorded. Analyzed. Studied by alien scientists. We're lab rats. And we don't even know the experiment. Reason 3. Membership requirements. Maybe there's a galactic community. A federation of civilizations. And there are standards for admission. You don't get to join until you meet certain criteria: unified planetary government, post-scarcity economics, resolved internal conflicts, developed interstellar travel independently, demonstrated sufficient ethical and technological maturity. We fail all of these. We're divided into competing nations. Our economy is based on scarcity and competition. We still wage wars. We've barely left our solar system. We use nuclear weapons, destroy our environment, and struggle with basic cooperation. From an advanced civilization's perspective, we're children. Dangerous children. Playing with weapons we don't understand. Destroying our own planet through ignorance. Why would they contact us? We're not ready. We'd be a liability. A threat. A disappointment. So they wait. Watching for signs of maturity. Waiting for us to solve our own problems. To prove we deserve admission to the galactic community. Reason 4. We're dangerous. Maybe they're not protecting us from them. Maybe they're protecting them from us. Humans are violent. Aggressive. Tribal. We've committed genocides against our own species. We've destroyed countless other species. We develop weapons first and ethics later. What if we're the scary ones? What if advanced civilizations look at humanity and see a species that must be contained? They might have quarantined Earth. Marked it as a dangerous world. Prohibited contact. Waiting to see if we'll mature or destroy ourselves. And if we ever develop interstellar travel while still being violent, tribal, and aggressive, they might intervene. Not with welcome, but with force. We might be living on a prison planet. And we don't leave until we've reformed. The zoo hypothesis has problems. Problem 1. Enforcement. If thousands of civilizations exist, they'd all need to agree not to contact us. All of them. Forever. One rogue civilization, one individual, one accident, and the zoo breaks. It requires perfect consistency across vast distances and long timescales. That seems implausible. Problem 2. Why are we special? If non-contact is the rule, why? What makes pre-spacefaring civilizations special enough to warrant protection? There should be thousands or millions of planets with life at various stages. Why establish elaborate observation protocols for all of them? Problem 3. No evidence. If we're being observed, where's the evidence? Shouldn't there be occasional slip-ups? Detected probes? Anomalies? Unless their technology is so advanced that detection is impossible. That they're watching using methods we can't conceive of. Observing from dimensions we can't access. If the zoo hypothesis is correct, what should we do? Keep developing. Keep trying to solve our problems. Keep advancing technologically and ethically. Because eventually, we'll either reach the criteria for contact, and they'll reveal themselves, destroy ourselves, and they'll note our failure and move on, develop technology to detect their observation, and the zoo will end. The zoo hypothesis is oddly comforting. It suggests aliens exist, they're benevolent enough to leave us alone, and we have a chance to join them eventually. But it's also disturbing. Because it means we're not in control. We're being judged. Our privacy is an illusion. And we might fail the test. But there's one final solution. One that requires no advanced aliens, no conspiracies, no hidden observers. One that's simple, consistent with all evidence, and absolutely terrifying. Let's talk about being alone. Chapter 4. The Rare Earth Hypothesis. We're the only ones. And the silence is real. What if the universe isn't teeming with life? What if Earth isn't typical? What if we're not average, but extraordinary? What if the silence of the cosmos is real because we're the only ones here? No aliens. No ancient civilizations. No galactic empire waiting to contact us. Just us. Alone in an incomprehensibly vast universe. This is the Rare Earth Hypothesis. And it's the loneliest solution to the Fermi paradox. The Rare Earth Hypothesis was formalized by paleontologist Peter Ward and astrobiologist Donald Brownlee in their 2000 book Rare Earth. Their argument: while simple life might be common, complex life, especially intelligent life, requires so many precise conditions that it's extremely rare. Earth isn't a typical planet. It's a cosmic lottery winner. And that lottery is so hard to win that we might be the only winners in billions of light years. Let's list what Earth has that might be rare. 1. The right star. Our Sun is a G-type main sequence star. Stable. Long-lived. Not too hot. Not too cool. Most stars are red dwarfs. Smaller, cooler, Planets around red dwarfs would be tidally locked. Extreme temperature differences. Frequent stellar flares. Probably uninhabitable. 2. The right orbit Earth is in the habitable zone, the Goldilocks zone where liquid water can exist. Not too close. Not too far. But it's not just distance. Earth's orbit is nearly circular. Many exoplanets have highly elliptical orbits, causing extreme seasonal variations that would prevent stable climates. 3. The right-size Earth is large enough to retain an atmosphere and maintain geological activity, but not so large that gravity prevents life from developing. Too small, loses atmosphere, core solidifies, no magnetic field, solar wind strips away remaining atmosphere. Too large, extreme gravity might prevent complex life. 4. A large moon. Earth's moon is unusually large relative to the planet. This stabilizes Earth's axial tilt, preventing extreme climate shifts. Without the moon, Earth's tilt would vary chaotically. Seasons would be unpredictable. Climate would be unstable. Complex life might not survive. The moon probably formed from a collision between Proto-Earth and a Mars-sized object. That collision had to occur at exactly the right angle and speed. Too hard, Earth is destroyed. Too soft, no moon forms. This might be a 1 in a million event. 5. Jupiter. Jupiter's massive gravity acts as a cosmic vacuum cleaner, deflecting or capturing asteroids and comets that would otherwise bombard Earth. Without Jupiter, Earth would be hit by extinction-level impacts far more frequently. Complex life couldn't establish itself. But Jupiter had to form at the right distance. Too close, it would destabilize Earth's orbit. Too far, it wouldn't protect Earth effectively. 6. Plate tectonics. Earth's crust is divided into plates that move, recycle carbon, regulate climate, create diverse environments. Most planets probably don't have plate tectonics. Without it, carbon gets locked in rocks. Greenhouse effect runs away or dies out entirely. Climate becomes inhospitable. 7. A magnetic field. Earth's liquid iron core generates a magnetic field that shields us from solar radiation and cosmic rays. Without it, radiation would strip away our atmosphere and sterilize the surface. Mars lost its magnetic field and became a dead world. 8. The right amount of water. Earth has water, essential for life. But not too much. If Earth had slightly more water, the entire surface would be ocean. No land. No mineral cycles. No complex ecosystems.